everybody. So this is just in case you don't get all of these right. So here are the 3 questions you are asked to do in class today with their answers. All you're getting is the answers. If you don't have an answer that is very close. Now again, please understand small rounding issues please are no big deal right now. They're no big deal. If you can get something close to this, you're good. If you got something anywhere off of it, then you don't need to consider you didn't do it right. Okay? If that's the case, I want you to watch the rest of the video. I've got 4 problems I'm going to work for you, and then there's 1 additional problem I just want to make sure you do. This is just so that you can learn how to work the problems and nothing else. You need to go ahead and when you finish the video, try these 3 problems again and see if by reworking them you can get the right answers and then resubmit it. Thank you. Okay, so here is extra practice number 1. Again, these are if you were not able to get the classroom practice problems done correctly. So this one is basically just a regular problem. It's asking for Q. Remember again, the formula is Q equals M C delta T, and you're going to be using this problem exactly this way. All right, so what do we have? We know the mass. There's the mass. We know the change in temperature, which is delta T, is going to be the difference between 44 and 11. Let's go ahead and calculate that. 44 is your final. 11 is your beginning, so that means your delta T is equal to 33 degrees C. All right, and then we know that this is water. And so when we come over here and we look at our specific heat capacity list, and this number will be different depending on who's writing it, is 4.186 according to this one. So we're going to say that C is equal to 4.186 joules per gram degrees Celsius. And I'm not going to make any of this really pretty just because I want to make sure we can get this figured out. So let's fill this in. Guys, if we have the formula, we figured out everything else. The only thing we don't know is Q. So M, 53.0 grams. C, 4.186 joules per gram degree Celsius. And then delta T is 33 degrees Celsius. There's your problem. That is filled in. Q equals MC delta T. All right. The whole point about this is, look, grams on the top and on the bottom, it cancels. C is on the top and on the bottom and the top. The only thing you have left is G, or joules, which is the energy. All right. And when you take 53, let's just run this through the calculator. It'd be really good. There we go. Got it turned on. 53 times 4.186 times 33. And we end up with Q equals 7321 joules. We aren't going to worry about any of the extra numbers because we ended up with, you know, somewhere in the range of somewhere between 2 to 3 sig figs. Okay, so that's problem number 1. Okay, guys, so here is question number 2. Now this one you have to pay attention to. It says it a little bit differently. How much heat is released when 21 grams of aluminum cools from 31.0 to 27.0 degrees Celsius? This again is still asking for heat, so we've got the problem. Q equals M C delta T. Let's find out what we have. We have M. All right, and mass in this particular case is going to be 21.0 grams. We're going to look it up. What is C for aluminum? Sorry, it looks like it's kind of messed up there. Aluminum is 0.902, so we are going to take 0.902 joules per gram degree Celsius. And then we're going to do delta T. Well, delta T, guys, is final, which is 27 degrees Celsius minus 31, which is initial, because that's the definition of delta T. Delta T isn't the biggest minus the littlest one. It is the final minus the initial. So in this particular case, guess what? It's a negative 4 degrees Celsius because it cooled off. So we're going to write -4 degrees Celsius. Be sure you actually pay attention to the fact that that said cools. Otherwise, you're going to end up with the wrong answer. And you're going to say it took energy rather than releasing energy. All right, guys, so that's all there is to this one. If you have we're asking for heat, all you have to do is fill it in. Let's go ahead and run these numbers. I have 21.0 times 0.902 times -4. And my number is -75.768. We'll go ahead and round that to -75.8 degrees. Excuse me, should not have been a degree Celsius. It's supposed to be joules. That's because I wasn't looking at my units. All right, look, grams cancel. C cancels, and the only unit that I have left is a J, which is why I was wrong when I was going with degrees C. All right, so the second one is a -75.8 joules, because we are looking for the Q in this particular case, having been given everything else. Okay, let's move to problem number 3. Okay, guys, here's question number 3. In this particular thing, we are asking to find out what C is. We don't know C. We know M, and we know Q, and we know that the temperature of increase, delta T, is 3.5 degrees Celsius. All right, so guys, what we are doing, and again, this is just the way I do it. You can rearrange it if you would like to. I would rather just put the numbers into where they're supposed to go. 50 joules equals 32.3 grams times question mark, which is going to be in joules per gram degree Celsius. That's C, times 3.5 degrees Celsius. All right, my way of working this problem, guys, is simply to isolate what I don't know. How am I going to do that? I'm going to divide both sides by 32.3 grams. All right, at that point, this one cancels. I'm now going to divide both sides by 3.5. Let me just put it down here so you can see what we're doing. And we're going to have 3.5 degrees Celsius on the bottom. Okay, notice everything has canceled on the right side of the equation except for what we are looking at for. And if you look at the units, joules, grams, degrees C, that's what I've got, joules, grams, degrees C. So now my job, guys, is just to do the math. And I'm going to take 50, and I'm going to divide it by 30.3, and I'm also going to divide it by 3.5. And my answer is going to be 0.442, which we would probably just round to 0.44 joules per gram degree Celsius. Now, I'm going to just say that some people are going to go, yeah, but there's a multiplication sign in there, Dr. B. And I'm going to say, well, if you want to do it this way, go for it. I'm going to say you can also do it this way and say, go ahead and simplify the bottom. And you're going to take 32.3 and multiply it by 3.5. That number altogether is 112.7 grams degrees Celsius. All right, so now rather than having to worry about this, you put this all in parentheses and you don't have a problem. If you don't put it in parentheses, your calculator's stupid. It's going to get you the wrong answer. All right, so we're going to take 50 and we're going to divide it by the answer we received there. And guess what? We are still going to get 0.44 joules grams degrees Celsius. Regardless of which way you do it, guys, you're going to get the same answer. All righty. So in that particular case, you just had to rearrange to try to find specific heat. Probably this would be iron. very close to it at least. There's probably something between iron that may not be there, but iron is 0.452. So this could be iron. Okay, guys, so this is the third problem you had in your problems today. This one may take just a second or two longer for you, but this isn't hard if you just think about what you are doing. Again, let's look at the equation. Q equals mc delta T. All right, so what do we know? We know we have 75 grams of water. Got that taken care of. We know that we used 8162.7 joules of energy to increase the temperature of that 75 grams of water. The initial temperature is 10 degrees Celsius. What we are trying to find is the final temperature. That's the question mark. What's the final temperature? Okay, we know the heat capacity of water is 4.186 joules per gram degrees C. Well, what's the final part of this equation? The final part of this equation is delta T. So let's solve the equation that we have for delta T. All right, so what are we going to do? We're going to divide both sides by 75. We're going to divide both sides by 4.186 joules per gram degrees Celsius. All right, look, those cancel. Grams cancels. What do we end up with is degrees C. When we look over on this side, joules cancel. Oh, sorry, the grams cancel. And the only thing we end up with is delta C, or degrees C. So we've got our problem set up correctly. This is at the bottom of the bottom. No, this is messy, but okay, so what do we have to do? We have to actually just do this math. Let me cover the other part off. All right, there was my original equation. I've isolated delta T on the right side. Okay, so let's do this. Let's take this calculator that I have right here, and let's do this math. And I'm going to say 8162.7. I already did it, so you can see that it is there, divided by 75, divided by 4.186. And I'm going to find that delta T is equal to 26 degrees Celsius. All of this being divided on this side, canceled him out, canceled him, divided here. So what I do on the left side, I do to the right side. So remember, when I divided 75 here, I have to divide by 75 over here. There's the grams. When I divide by the C on this side to isolate delta T, I had to do the same thing. There is C on this side, and I have joules, grams, degrees C. Okay, so I know this looks busy, but all I'm doing is solving for T. You can rearrange, and you end up with Q equals M over C equals delta T. That's what this math is. That's what this math is right here. Okay, so delta T is 26. So guys, how do we calculate delta T? Delta T is equal to final temp minus initial temp. Okay, so what do we already know? We know the final temperature is 26. We know the initial temperature was 10. So guys, 26 equals the final temperature minus 10. Final temperature, I know we're having to skip around, is equal to 26 plus 10. The final temperature is 36 degrees Celsius. All right, so this one's a little bit tougher just because you have a little bit more mess in it. But guys, you know how to do this. You know that the delta T is the final temperature minus the initial. If you know what the initial is, you can calculate the final. You first go ahead and calculate delta T. All right? So there's the third or the fourth one. Okay, so this last question is a question that I don't think we're going to ask you to do this year, but I can't not share it with you. All right? So in this particular question, it says how much heat is required to change 25 grams of liquid water into steam water vapor. All right? So the idea here, though, guys, is that if you were doing what we've been doing before, I'm just going to put the equation. I'm going to put Q equals MC delta T. That's not the right problem in this particular case, because what I'm going to ask you to look at again, it says how much heat is required to change water liquid into steam. This is a phase change, isn't it? And does temperature increase in a phase change? The answer is, of course, a resounding no. When we did this last week, we talked about the heating curve, and we saw the heating curve and we did this. And if you remember, we identified this amount of energy is the heat of fusion. And it is approximately 80 calories per gram, which is actually 334 joules per gram. Again, we're not asking you to know these numbers. The heat of vaporization is 500. I'm going to get the wrong number here all of a sudden. 540, I believe it is. 520. Hang on. 2260 divided by 4.186. 540, I was right. 540 calories per gram. Or in joules, 2260 joules per gram. Okay? So when this problem is being asked, you're not being asked to do this problem. This is not the problem you're being asked to do. What you are being asked to do is to simply take the mass times, in this particular case, since we're going from water into steam, we're using the heat of vaporization, times the heat of vaporization. All right, so I'm just going to run this problem. We got 25 grams, and we're going to do this in joules, and we're going to say 22.6 joules per gram. So this is, supposed to be grams. That's the problem that we're working, okay? That is the problem we're working. And when we take 25 grams times 2260 joules per gram, we know that it takes 56,500 joules of energy to turn 25 grams of liquid water into steam. Okay? So please understand, when you see a problem like this, should you see one, you are not doing the basic Q equals MC delta T problem. You are doing a problem that is simply looking at how the mass times the heat of vaporization. If it was a melt, it was an ice to liquid problem, then it would have been 25 grams times 334 joules per gram. Okay, so it's either mass heat of vaporization, or it's going to be the mass times the delta H, which is this, of fusion. All right, So just make sure this is just kind of a thing for you to be able to see. All right. Thank you guys very much. I hope if you needed to see it, I hope you got something out of it. If not, we'll keep trying, okay? Thanks, guys.